Hey y'all, here we have a ordinary differential equation problem that we're going to solve using the method of separation of variables. So what this method says is that basically you have to isolate the variables to their own side. So say for example, we move all the y's to the left hand side and all the x's to the right hand side. That is what we mean by separation of variables. All right, let's get started. Okay, so the first thing I notice is that we can factor both the numerator and the denominator using factoring by grouping. So that is what I'm doing here. I can see I can factor out an x from the first two terms in the numerator, and we can factor out -1 from the next two terms. And then in the denominator, we can factor out an x from the first two terms in the denominator, and then a 4 from the next two terms. And so our new differential equation is now x minus 1 times y plus 3 over x plus 4 times y minus 2. Now we are going to separate these variables. We're going to bring over y minus 2 over y plus 3 to the left hand side and integrate that, and then on the right hand side we'll leave x minus 1 over x plus 4 there, and then integrate that. Next, I'm going to go ahead and split up the terms on the left hand side and the right hand side. So now we have y over y plus 3 dy minus the integral of 2 over y plus 3 dy, which will equal x over x plus 4 dx, the integral of x over x plus 4 dx, minus the integral of 1 over x plus 4 dx. Now this is where it gets particularly interesting. So the integral of y over y plus 3 and the integral of x over x plus 4 would both require long division in order to make those integration problems easier. So that's what we're going to do next. So now we'll divide y by y plus 3. To make this problem easier, what I'm going to do is add a plus 3 and a minus 3 to the dividend in order to make this long division problem easier. In doing that, we see that y plus 3 goes into y plus 3 once, and then we'll have a remainder of -3. So now our new expression is 1 minus 3 over y plus 3. The next thing we want to do is check this to make sure that we get the original expression, which was y over y plus 3. And we see that it checks. So next we're going to do the same thing to the x over x plus 4 now. Using long division, I'm going to add a plus 4 and a -4 to the dividend to make it easier. And then we're left with a remainder of -4. So now our new expression is 1 minus 4 over x plus 4. And just like the other one, we're going to go ahead and check it to make sure we get x over x plus 4. And it checks. So now we're going to use these two new expressions in place of the other one to make the integration easier. So now we have the integral of 1 minus 3 over y plus 3 in replace of y over y plus 3. and the minus integral of 2 over y plus 3 dy. And then on the right hand side, we're going to replace x over x plus 4 with 1 minus 4 over x plus 4. And then we have the other integral of 1 over x plus 4 dx. Okay, so now we can actually combine terms here. So if we look at the negative 3 and the negative 2, they're basically the same. So I'm going to combine that into one term, and it's going to be 5 of y plus 3. So now we have a single integral of 1 minus 5 over y plus 3 dy. And now we'll integrate this. As you can see, it is easier than what we had before with the y over y plus 3 and the x over x plus 4, because now we can just use the integral of du over u, which is the natural log of u. So now we have 1 minus 5 natural log of the absolute value y plus 3 plus c, which is our integration constant. Then on the right hand side, x minus 5 natural log of absolute value of x plus 4. So what we're going to do now is move the natural log all to one side and move all the other terms to the other side. Now we'll use our properties of logarithm to condense these two logarithms into one. Now we can just go right ahead and solve this. Now let's go ahead and rewrite the left-hand side. So e to the y over e to the x, and then our integration constant, we could just call it c, because e to the c is just a number at this point. So we'll just rename that to just simply c. And then on the right-hand side, we'll bring that down. Next, we'll go ahead and clear the fractions. And there we have it. We solved this differential equation using separation of variables. The main trick here that we wanted to do was use long division to make those two integrals easier to solve. After we did that, it made the entire differential equation easier for us to solve. So this is how you use separation of variables. It's probably one of the easiest ways to solve a differential equation, assuming of course you can indeed separate those variables to their respective sides. So if you have any questions or comments, please leave them below in the comments section. And until next time, guys, take care.